Hello everyone, welcome back to our physics session. Today we are dividing into some highly important repeating previous year questions from class 10th electricity. Let's jump into the conceptual numerical asked in CBSE 2025. The question says calculate the amount of work done by a cell when 20 coulomb of charge is moved through a potential difference of 3 volt. Before solving, always remember two fundamental tools on your screen. Potential difference is measured by a voltmeter and electric current is measured by an ammeter. Now look at step 1 under given. Charge Q is equal to 20 coulomb, potential difference V is equal to 3 volt, work done हमें फाइंड करना है. मूविंग टू स्टेप 2, our golden formula relation these three parameters in W is equal to V into Q. Let's substitute the value in step 3. W is equal to V multiplied by 20. That gives us 60 joules. So option C is our absolute correct answer. Now let's move on to our second slide. A core conceptual question from CBSE 2023. The exam asked up to find the correct mathematical expression that relate QIT and QVW simultaneously. Let's look at the solution blocks symmetrically. First, the standard relationship for electric current is I is equal to Q divided by time. By cross multiplying, we find Q is equal to I multiplied by T. Charge is equal to current into time. Similarly, potential difference is defined as work done per unit charge, meaning V is equal to W upon Q. Rearranging this, given us W is equal to V cross Q. Work done is equal to potential difference multiplied by charge. Scanning through the given option, we can clearly see that option B perfectly matches both of our derived conditions. Keep our handy formula box down on the bottom right corner. Memorized, it will help you solve multiple choice question within seconds. Now let's look at critical concept that students often confuse with regular resistance, resistivity denoted by rho. First things first, note these key facts down. Resistivity is an inherent property of the material itself. Unlike resistance, it does not change with a change in the length or area of cross section of the material. Its standard unit is ohm meter. Look at the trend order show on the screen. Metal, alloys, insulators. This brings us to a prominent question from CBSE 2025 and 2017. How is the resistivity of alloys compared with those of pure metals from which they have been formed? The answer is right in the order bar. The resistivity of an alloy is generally higher than that of all constituent pure metals. This is precisely why alloy don't oxidize or burn easily at high temperature, making them perfect heating elements. Let's wrap up today's session with a heavyweight problem that has hit the board exam multiple times, including 2024, 23 and 20. The problem states the potential difference across the two ends of a circuit components is decreased to 1/3 of its initial value, while its resistance remain constant. What change will be observed in the current? Also name and state the law that help us answer. Let's break this into our structure solution framework. Given potential difference V nu is equal to 1 by 3 volt and resistance R is equal to constant. The law. This entire scenario is Governed by Ohm's law, it states that at a constant temperature, the current flowing through a conductor is directly proportional to the potential difference across its ends, V proportional I. Conclusion: since R is resistance, current I tracks potential difference V uh, symmet- uh, symmetrically. If V becomes one third, the electrical current flowing through the component will also automatically decreases to one third of its initial value. Okay, note this complete answer down exactly as shown and you will lock your full marks on this chapter. Thank you for joining and I will see you in our next class.